Hello everybody and welcome to the Informal Fallacies Part 3 lecture. This time we'll be talking about hasty conclusions, small sampling errors, unrepresentative samples, questionable cause, questionable analogy, questionable statistics, and the questionable use of good statistics, including the special case of biased polling. This is our last major section dedicated specifically to named list of informal fallacies, but this doesn't mean that we have covered all the informal fallacies out there. There are many, many more. Remember that some of these categories are quite broad, and some of the name fallacies are subsets of other broader categories. Last time, for example, we saw that a non sequitur was a very broad category. This time we will see that hasty conclusion is a broad category as well. In our first look at informal fallacies, we examined several appeal fallacies, such as appeal to authority, appeal to ignorance, and so on. But there are dozens, if not hundreds, of possible fallacious appeals. One could appeal to force, might makes right, or appeal to pity, or appeal to fear, many commercials do this, or appeal to anger, and so on. My point is simply that you shouldn't take the lists we have discussed to be comprehensive. It is good to remember the most common specific fallacy types, but it is also important to learn how to recognize bad reasoning and the very broad fallacy categories. At that point, one can then ask if there is already a more specific name for the flaw in reasoning being committed. With all that said, let's move on. I have mentioned this in previous PowerPoints on informal fallacies, but it is important enough to mention again. With informal fallacies, there are often fallacious and non-fallacious versions. There are good uses of statistics and fallacious uses. There are sometimes legitimate reasons to draw conclusions fairly quickly without it being a hasty conclusion fallacy. Good analogous reasoning can be quite strong, and there are plenty of polls that are unbiased. One of the fallacy types not really discussed in this lecture but mentioned in Cavender and Kahane's book is the false charge of fallacy. One doesn't want to jump to the conclusion that a fallacy is committed because it might superficially look like one. Remember, for example, that in the last lecture there are perfectly legitimate slippery slope arguments and there are slippery slope fallacies. With inductive logic, unlike with deductive logic, you cannot simply look at the form of an argument and tell if it is a fallacy. Content matters. So, while a deductive fallacy, like affirming the consequence, is always fallacious, even something like attacking a person's character might be relevant and not an ad hominem fallacy if that person's character is actually what is at issue in the argument. Now, the hasty conclusion is a very broad fallacy type. One is guilty of this fallacy when one reaches a conclusion based on information that is relevant, so it isn't a non sequitur, but is nevertheless insufficient for reaching that conclusion. Here is an example. Suppose that you are missing your cell phone. You thought you had put it in your pocket, but when you reach for it, it isn't there. Should you immediately jump to the conclusion that it is stolen? Probably not. It certainly might have been stolen. The fact that your phone isn't in your pocket is relevant to the possibility of it having been stolen. But if you are a normal person with normal memory, you probably forget where you have placed your possessions more often than you have had your possessions stolen. It would be more reasonable to look in several places for your cell phone before concluding that it has been stolen, unless you have some other good reason to think that it has been. Again, notice the nature of informal fallacies and inductive reasoning here. If you were a person with perfect memory, such that you were certain that you put it in your pocket just a moment ago, and the only thing that had happened to you in the meantime was that somebody bumped into you on the side that you carry your cell phone, on a crowded street, well, then concluding that your phone had been stolen might not be a hasty conclusion for you. It sounds instead like you have a good reason to think that your cell phone was pickpocketed. But under normal circumstances, you probably reached a hasty conclusion. One more very important thing to note. Just as with other fallacies we have been discussing, this has nothing to do with whether or not you are actually right by chance or by luck. Suppose you are missing your phone, so you jump to the conclusion that not only was it stolen, but that it was stolen by a woman. And not only just that, it was stolen by a woman, but that it was stolen by a woman with red hair. And not just that it was stolen by a woman with red hair, but that it was stolen by a woman with red hair wearing a blue pantsuit. You have no good reason to believe that this is true. You haven't seen such a woman. You just jump to that conclusion. Now suppose that as a matter of purest luck you are right. Not only was your phone stolen, it was stolen by a woman matching this description. That doesn't mean that you're not guilty of reaching a hasty conclusion. It just means that your wild, unfounded guess was in some sense lucky. It's as if Mr. Flippy went to Vegas and put his entire family's life savings on green 00, won, and walked out a millionaire. That doesn't mean that Mr. Flippy is a brilliant financial investor. It means that Mr. Flippy is a tremendous idiot who happened to get incredibly lucky in spite of himself. Here is a rather amusing example in a commercial about reaching hasty conclusions. Remember that in order to pause the PowerPoint, you can move your mouse pointer to the bottom of the screen. A menu should pop up. On one of those menu options, there should be a sub-option to pause the presentation. Once you do that, you can click on the image to start the video. The video should open in a new browser window. Once you are finished viewing it, just click in the PowerPoint and it should restart again. You can't do that if you're viewing this on YouTube, but there should be separate links. I'll count down from 5 to give you time to pause. 5, 4, 3, 2, and 1. Okay, now for the fallacy of using too small of a sample. One commits this fallacy when one makes an inference about a property or properties of a population through examination of too small of a subset of that population. We've talked about sampling before, and I believe we used a gumball machine as an analogy. This works well as an analogy, so we will use it here as well. See, reasoning by analogy. We are using our concepts. Imagine that you have a gumball machine, but that the glass of this machine is opaque, so that you don't know what kind of gumballs it contains. Now imagine that you buy 2 gumballs and that both are cherry, and so you reach the conclusion that all the gumballs must be cherry. What is the problem here? The problem is that the gumball machine likely contains hundreds of gumballs, and yet you only sampled 2 of them to reach your conclusion that they were all cherry. Suppose that the gumball machine contains equal portions of cherry and grape. If that were the case, then your odds of getting 2 of the same flavor are actually 50-50. It doesn't matter what the first flavor is, cherry or grape, the chances of the other flavor matching it are 1/2. You can test this with 2 fair coins. Flip them both, and half the time they should match. So if the gumball machine had only 2 flavors, then half the time you would wrongly conclude that it had only 1 flavor based on a sample of 2. It is also worth mentioning that reaching a conclusion based on too small of a sample is a subset of a broader fallacy type. Can you think of which one it is? You can pause to consider the question if you wish. The broader fallacy type is hasty conclusion. You sample 2 gumballs and reach the hasty conclusion that the gumball machine contains only 1 flavor of gumball. How do you reach a better conclusion? Sample 10 or 20 gumballs. That will give you a much better sample size. How can you make it even better than that? Apart from an even larger sample size, you can shake the machine to mix up the gumballs to make sure that you get a more representative sample. We will talk about unrepresentative samples later, but just consider that maybe the person filling the machine first filled it with cherry gumballs, and then when the machine was half out, filled it back to the top with grape. If you don't mix up the gumballs, what flavor are you likely to get even if you buy 10 or 20 of them? Okay, here is a very nice explanation of the problem with using small sample sizes. It is about 10 minutes long, but it is very good, and it explains the issue very well. Again, I will count down from 5 so that you can pause to play it. 5, 4, 3, 2, and 1. Here is another kind of sampling error, the unrepresentative sample. One commits this fallacy when one reaches a conclusion about the property or properties of a given population based on sampling a subpopulation that doesn't reflect the relevant characteristic or characteristics of the population. We've already went through an example with gumballs, which you have hopefully considered. If all of the cherry gumballs are sitting at the bottom and all the grape ones are sitting at the top, then even if you take a large sample, you are still likely to get all cherries, and will reach the faulty conclusion that the gumball machine contains only cherry gumballs. One way to fix this would be to mix up the gumballs in the machine, or to pick them out randomly instead of using the dispenser at the bottom. Here is another example for variation. Suppose that I am your manager, and that I want to know how you spend your time at the office. To do this, I decide to sample what you do during the day. So every workday that month I come in between 12 noon and 1 p.m. and I notice that you are never at your computer like you should be. Sometimes you are chatting with people, sometimes you're at the soda machine, sometimes you are not in the office at all. So I reach the conclusion that you're a terrible employee and start writing up your pink slip. How might my reasoning be flawed here? Any ideas? One obvious problem is that I am always sampling how you spend your time between noon and 1 p.m. Many employees habitually take their lunch at the same time every day. If this was your normal time for lunch break, it would not be unusual or derelict for you to be chatting with other employees, or at the soda machine, or out of the office entirely. All the other hours you are at work, you might be glued to your chair working feverishly. At lunch, you might be taking your much-needed and deserved break to keep your energy up. My poor reasoning could cost me my best employee and get me on the wrong end of a lawsuit in the bargain. Again, you should notice that a small sample is a subset of the unrepresentative sampling fallacy. Having too small of a sample is just one way to get samples that aren't actually representative. Questionable cause. This fallacy is committed when we conclude that something was the cause of something else without sufficient reason or warrant for reaching that conclusion. There are several ways we might fail to have sufficient warrant. Here are just a few. The cause might be questionable because of any number of the fallacies regarding causation we have already mentioned, such as the post hoc fallacy, before therefore the cause of, or an appeal to ignorance. Maybe the cause postulated contradicts a well-founded higher-level reason to reject that cause. Of course, higher-level reasons can themselves be rejected, but if we have a well-supported higher-level reason, then we need to have good evidence to overturn that claim. If I come home and find that my house is a mess, angry gremlins might be the cause of it. But given that I have a lot of higher-level reasons not to believe in critters such as gremlins, I could probably reject that as a cause unless I had a very good reason to reconsider it, such as maybe finding one of them caught in a mousetrap. Having too small of a sample or unrepresentative sample can also lead to falling for the questionable cause fallacy. Suppose I sample a population and find that 70% of the people who eat liver 3 times a week die on average 3 years earlier than non-liver eaters. This might seem significant, and perhaps it would be, but if my sample is not representative, suppose all the liver eaters I sampled were people who were also smokers, then my study likely isn't very good. Likewise, if I only sampled 2 liver eaters, pure chance could have thrown off my survey. Reasoning by analogy is incredibly useful. We've done so in this class numerous times already, but it can go very wrong very fast if one is comparing 2 or more things that seem similar in some respects, but are not similar in the relevant ways. There are lots of ways analogies can go wrong, and here are just a few. Too small a sample size might result in one making a bad analogy. Or again, one might use an analogy in spite of it contradicting well-established higher-level theories. Or the items said to be alike might not be alike in the relevant respects, even though they are superficially alike. Suppose that I say, life is like ice cream. This is actually a metaphor in a famous poem, and it is a good one for the point it was trying to make. Life is a sweet thing, but it is slowly and inevitably melting away. You can enjoy it while you have it or not. But, as a general analogy for life, it wouldn't be very good. It makes that one point about life, but if you tried to draw other conclusions about life based on ice cream, you wouldn't be able to do so. You wouldn't be able to say, for example, life is a dairy product, or people live longer at freezing temperatures, or that we would all be better off if we lived in waffle cones instead of houses. Here are a couple examples of weak analogies. As always, Futurama is a great source of humorous fallacy examples. The other is an amazingly bad analogy from a car commercial. I have no idea why you have to turn YouTube's safety mode off to view the car commercial. As far as I can tell, there's nothing offensive in it apart from its assault on reason. My guess is that YouTube's auto-translate for closed captioning mistranslated something as sexual and then censored its own mistranslation, but that is just a guess. Anyway, here are two examples. Questionable statistics. One can fall for questionable statistics when one accepts as authoritative statistics that are unlikely to be accurate. These statistics might be flawed for numerous reasons, just some of which are as follows. The statistics might be impossible to know or to know with the accuracy implied. Suppose, for example, that you're told that 1/3 of Americans are racist. How could this be known? Would 1/3 of Americans admit to being racist in a poll? Are they being judged as racist by some action they commit or position they hold? If so, then it would be more accurate to say that 1/3 of Americans commit some action or hold some position, since it might be up for interpretation whether such an act or position is always racist. Here's one of my favorite examples of a statistic like this that is often passed off as real. You will hear people say on the internet and even TV and radio that people swallow 8 spiders every year in their sleep. People get kind of grossed out thrill from this and gleefully pass it on as a meme. But there is no scientific evidence to back this up at all. How would anybody know this? Did scientists film hundreds of people sleeping for a year with night vision cameras focused on their mouths, however they turned in bed? Did they do so in all parts of the world? Because certainly the number of spiders living in an area and their behavior varies by climate and location. What would motivate somebody to spend such tremendous resources on such a study? Nobody has. People do end up eating quite a few insects, arachnids, and other things they wouldn't normally voluntarily eat, but they do so because of insects that get into grains and fruits and juices when they are grown, harvested, and processed. These people do know because people have reasons to test content and quality of food. Another common problem is the margin of error of studies. The people conducting the studies often understand the margin of error, but the people using the studies, and oftentimes when studies are published in popular mediums such as newspaper and when broadcast on television, the margin of error is not given. Suppose I say that this year's support for the death penalty is 49%, and last year it was 52%, and that therefore support for the death penalty is dropping. Is this a good conclusion? Suppose that the margin of error for these studies is 6%. Maybe this year it is really the case that 54% support it, and last year it was really the case that 51% of the people did. That is within the margin of error. Often changes in statistics might be the result of how those statistics are calculated instead of any real-world changes. Suppose that the government wants to show a drop in unemployment. One way to do this would be if unemployment actually dropped. But another way would be to redefine what it is to be unemployed. If you count people with just a couple hours of work a week as employed, and when you didn't last year, unemployment appears to drop. Or if you don't count people who haven't applied for a job because they have given up, as they've applied for all the jobs they are qualified for in their location, it appears to go down. If the police want to make crime statistics look better, they might be able to say cases are closed even though they might not have been solved, or redefine what it is considered to be a violent crime, and so forth. Such statistical sleights of hand are often hard to spot. This is why it becomes helpful to learn which news sources and watchdog groups are more trustworthy and which manipulate the facts for their own ends. Of course, in order to do this, one needs to check up on these groups oneself occasionally. Even good statistics can be misused if one uses them to reach conclusions that are not warranted by those statistics. This can happen if one really doesn't know what those statistics imply, as is often the case with scientific information. Another major problem is the problem with causation that we have discussed, especially that of confusing correlation with causation. Two things might be correlated, but it might not be the case that one causes the other. Thus, a perfectly good study might show a correlation between two facts, A and B, and yet A doesn't cause B. Maybe B causes A. Or maybe A and B are both caused by C. Or maybe A being correlated with B is temporary and a coincidence. A correlation is a good reason to suspect causation, but it is not sufficient. Buying new cars, for example, might be correlated with a strong economy. But buying new cars doesn't cause the economy to be strong, though it likely helps car companies. It is far more likely that when people have more money, one of the things they happen to do is buy new cars. It is likely that people who play video games are less likely to have heart attacks than people who play bingo, but it is unlikely that video games helps prevent heart attacks or that playing bingo helps cause them. It is far more likely that younger people who tend to play video games are less likely to have heart attacks than older people who tend to play bingo. One shouldn't think that these are the only ways that good statistics can be used wrongly either. There are too many ways to list. There is an old saying that there are lies, damn lies, in statistics. This is of course not true. Statistics are incredibly useful. Science wouldn't be able to progress very far or very fast without statistical analysis. Nevertheless, there is truth to the fact that statistics can be used to deceive, and further that people can be deceived by them unintentionally. One form of questionable use of good statistics is questionable polling. Polling might be questionable because of too small of a sample or an unrepresentative sample, but with polling an especially worrisome issue is question wording. Both the way questions are worded and the questions that come before the particular question that the pollsters are interested in can have a terrific influence on the outcome of polls. Even the places that the same people are polled can have a dramatic effect on their responses. People answer survey questions differently if they have just left church, or if they've had a drink, or if they are relaxing, or if they are hungry, and so forth. Indeed, psychological studies have shown the surprising results that people tend to answer questions more conservatively if they are within eyesight of a hand sanitizer machine, or if they have had a couple of alcoholic drinks. Very subtle things can affect how we answer questions. This doesn't mean that polling or statistics in general can be ignored. They are very useful tools. But it means that one needs to make every effort to poll fairly, one needs to learn who tends to take reputable polls, and when possible, one needs to know the wording of all the questions asked. Once again, wording can be very important. Here is an example. Do you suppose people would answer these two questions the same way? Do you support allowing doctors to assist those dying of a terminal illness to die painlessly if the patient pleads with them to do so? Versus, do you support allowing doctors to murder the terminally ill before they die naturally? I think chances are many people at least would answer these two questions very differently. Ideally, polls are used to find out what people actually believe. Here is an excellent example of how polls can be used to get a desired answer instead. This is from the series Yes Minister and Yes Prime Minister. One is the sequel to the other, and I forget which this is from. I think it is from Yes Prime Minister. This series contains many marvelous examples of fallacies and manipulation using language. I will count down from 5 so that you may pause to play the clip. 5, 4, 3, 2, and 1. Okay, while we are on the subject of polling, it is worth mentioning the problem of push polling. Push polling is a tactic often used for political or social ends in which people with a particular ideology or goal ostensibly take a poll with the real aim of manipulating the beliefs of the people whose beliefs they are pretending to measure. For example, in the 2000 primary election, George Bush's people used a push poll to undermine Senator McCain's campaign by asking people, in a poll, if they would be more or less likely to vote for Senator McCain if they were to find out that he fathered an illegitimate black child. Of course, there was no reason at all to suspect Senator McCain had ever done such a thing, and Bush's people knew this. The point of the poll wasn't to find out how people would feel about this, it was to spread the rumor in a particular targeted population that McCain had fathered an illegitimate black child. It was a type of whisper campaign against Senator McCain. And that is the end of this presentation for this module. I hope that you found it useful. The next module should be especially interesting as it will be discussing some of the psychological issues that can get in the way of good reasoning. Until next time.